So I move pretty fast because I don't have a lot of time and I still got a lot to do before classes start in 40 minutes. This is a sum of two cubes pattern. Formula's given to you right there. This is a 2x that's been cubed plus a 5 that's been cubed. If you have number sense, that makes sense. So everywhere I see an a, I'm going to be a 2x, and everywhere I see a b, I'm going to be a 5. So it's going to start off with 2x plus 5, then a 2x squared, which is 4x squared, minus 2x times 5, which is 10x, and then plus 5 squared, which is 25. Still equal to a 0. By ZPP, 2x plus 5 is a 0, so x is going to be negative 5 halves. Now, over here, you're going to have to use a QF. Remember, this piece is always your imaginary solutions. So you're going to do x equals negative b plus or minus square root b squared minus 4ac all over, not e. Don't know how that happened. All over 2a, and a is 4. All right, so what we have in this radical, 10 squared is 100. 4 times 25 is 100, times 4 is 400. 100 minus 400 is negative 300. So we have x equals 10 over 8, plus or minus the root of negative 300, also over 8. Now, root of negative 300 is going to be the root of 100 times 3. And of course, it's imaginary because it's negative. So it's going to be 10i, which my board would keep up with me, root 3. Now, 10 over 8 is 5 over 4. If we put this 10i root 3 over 8, we're also going to have 5 over 4. We're going to have an I, and we're going to have a square root of 3. Easy peasy. Moving forward. Let's see, I've got 4 and 5 bolded. The idea here was isolate the radical. That's what it was. So we're going to add 2. The root of negative 2x plus 3 is 12. The opposite of squaring is, the opposite of square rooting is squaring. 12 squared is 144. The 2's cancel. Negative 2x plus 3 is 144. You don't get a pretty answer on this one. You get negative 2x equals 141, assuming I've done everything right. Looks like I have. So x is just negative 141 over 2. I don't really want your decimal. And if there's only one answer, you don't have to check it. You don't. If there's two answers, by God, check it. All right, so we're going to add 6 to both sides. Negative 4 square roots of x is going to be negative 14. Normally, we would play the isolation game, but it's going to create a fraction, so I'm just going to square both sides. I can do that with multiplication. I can't do it with addition, but I can do it with multiplication. Now, a negative 4 squared is 16. A root of x squared is x, and that's going to equal 196. Check myself on that real quick. That seems, yeah, it's 196. We're going to divide through by 16, and that's going to give me that x is, well, it's not nice, is it? Let's see, they're both even. So what do we get? We get 98 over 8, 49 over 4. Seems legit. 49 fourths. All right, didn't have to check either one of those. Be right back. My wife is messaging me. She must need something. Always reply to your wife. 10 is probably the hardest one on here because you're cubing to fix a cube root. And of course, that makes this side easy. That side's just 8x cubed minus 1. It's the right-hand side that's a pain in the butt, because if you're going to cube something, you are going to have to turn around and write it 3 times, okay? So let's figure out what 2x minus 1 times 2x minus 1 is, which is 4x squared minus 4x plus 1. And then we're going to have to turn around and distribute again. So I got a 4x squared times 2x. Blah. Let's just go off the side and do a box. As much as I don't want to waste the time on a box, let's do a box. As a class, you'll have more success with a box than you will with the double distributive property, or in this case, the triple distributive property. 4x squared times 2x is 8x cubed. I'm glad I saw that. 4x times negative 4x is negative 8x squared. I'll explain why in a minute. 2x times 1 is 2x minus 4x squared. Negative 1 times negative 4, positive 4. Don't forget the x. Negative 1 times 1 is negative 1. So the right-hand side becomes 8x cubed minus 12x squared plus 6x minus 1, and still equal to 8x cubed minus 1. Now, the 8x cubes are in balance. They're going to annihilate each other. So are the 1s. They annihilate each other. And we get 0 equals negative 12x squared plus 6x. Now, your favorite F word, whether you believe it or not, is factoring. And these are both divisible by a negative 6x. If you pull a negative 6x from negative 12x squared, you have a 2x left. If you pull a negative 6x from positive 6x, you have a minus 1. Now we're going to use the ZPP, the zero product property. Negative 6x is a 0, which means that x is 0, or 2x minus 1 is a 0, which means that x is 1/2. Do they work? Okay, well, let's find out. I'm going to plug the 0 into the right-hand side, okay? So if I plug a 0 in here, this is going to be 0 minus 1, which is negative 1. To take a cubic root in a TI-84, you need to use, by the way, always wrap negatives. It won't hurt you on an odd root, but it will kill you on an even root. Negative 1. So I get a negative 1 on the left-hand side. The right-hand side would be twice a 0 minus 1. I don't know why I'm pushing buttons on this. I'm just showing you that you can do this. I'm a little curious why oh, because I use a double set of parentheses. Twice a 0 minus 1. Oops, it's negative 1 as well. So the 0 checks is a valid answer. Does the 1/2 check? Let's find out. So we're going to plug a 1/2 in. We have 8 times a 1/2. I believe that was cubed too. And then minus 1, or is it plus 1? Minus 1. I am supposed to take the cubic root of that, which is obviously going to be a 0. Perfect. If I plug a 1/2 in here, 2 times a 1/2 is 1, 1 minus 1 is 0. So they both check out and they're both real. All right, so that wasn't so bad. It really wasn't. All right, if you have two radicals, you isolate one of them. I'm going to go ahead and just isolate this one. Root 2x plus 3 equals root 3x plus 3, and then 4 minus 3 is 1, plus 1. The opposite of squaring is, the opposite of square rooting is squaring. That's going to free up 2x plus 3 here. If you're going to square something, you're going to write it twice. This is where you get kids say IDK. It's not IDK, it's just you lazy. That's all there is to it. Quit being lazy. All right, now the fun part. A root of 3x plus 3 times a root of 3x plus 3 is 3x plus 3. A root of 3x plus 3 times 1 is plus a root of 3x plus 3. 1 times root of 3x plus 3 is another root of 3x plus 3. And then 1 times 1 is 1. And we're still equal to 2x plus 3. If we combine like terms, we'll discover that we have two roots of 3x plus 3. I'm going to go ahead and shift my x's left. 2x minus x is negative x. 3 minus 3 is 0, minus 1. Now, I would not divide this 2 out because it will make the next line uglier. So, since it's multiplication, I can get away with this. I can because we have this property ab to the x is a to the x, b to the x. Remember that little girl right there? That's the one. 2 squared is 4. If you square this, you get 3x plus 3. And this guy's got to be written twice. Negative x minus 1 times negative x minus 1, which is x squared plus x plus 2x plus 1. And that equals this guy, which is going to be 12x plus 12. We're going to shift everything left, set it equal to 0, use ZPP. X squared, 2x minus 12x is negative 10x. 1 minus 12 is negative 11. Will she factor? By God, she will. x minus 11 times x plus 1 is my zeros, my factors. The zeros are 11 or negative 1 because I know how to use the zero product property. Now, does it work? All right, so if I plug in an 11 here, that's 22. 22 plus 3 is 25. The square root of 25 is 5. 5 plus 3 is 8. I got an 8 on the left. 3 times 11 is 33. Plus 3 is 36. Square root of 36 is 6. 6 plus 4 is 10. Let me go back over that, make sure I did it right. This was a 25. Square root of 25 is 5, plus 3 is 8. So 8 is equal to 10? No, that one's extra. Let's plug the negative 1 in. Twice a negative 1 is negative 2. Negative 2 plus 3 is 1. Square root of 1 is 1. 1 plus 3 is 4. Cool. Got a 4 on this side. 3 times negative 1 is negative 3. Negative 3 plus 3 is 0. Square root of 0 is 0. 0 plus 4, 4. This one is real. And moving forward, I did 14, and then I think I did all of those. All right, so you're supposed to solve for y. First thing we're going to do is we're going to fix division. The opposite of division is multiplication. This is where things get rough for kids. The opposite of a square root is a square. 26 squared, I don't know that one off the top of my head. It's not one I ever bothered to remember. I feel like it should. 676. 676x squared is 2y. Now divide out the 2, and you'll be done. 676 over 2 should be 300 and what? 38? 338x squared is my y value. Easy peasy lemon squeezy. I'm going to pause right before I do this little group. I will be right back. All right, last little grouping here. So while I was paused, I just typed some stuff out for you. So to find f of g of negative 2, which is read f composed of g composed of negative 2, we're going to plug a negative 2 into g. So we'll do that first. G of negative 2 is 2 times a negative 2 squared plus 3. Notation is going to kill y'all. That's going to be 4 times 2 is 8. 8 plus 3 is 11. And now what we're finding is we're going to find f of 11. Okay? I'm going to plug 11 into this one. It's 3 times an 11 minus 4, which is 33 minus 4, which is 30. Yeah, not 33. It's not 30. It's 29. All right. Vice versa, g of f of 3. We're going to find f of 3 first. We got to figure this piece out, kids, okay? F of 3, we let x be 3 in f. And we're going to get a 5 back. So this piece is literally now a 5. So now we find g of 5, which is twice a 5 squared plus 3. 5 squared is 25 times 2 is 50 plus 3 is 53. All right, this literally means add the two functions together. You're doing 3x minus 4 plus 2x squared plus 3. Now, if you can't do that, I don't know how you made it to be a junior. Standard form, 2x squared plus 3x, and negative 4 plus 3 is minus 1. 17 literally means subtract g from f. Just be careful about parentheses. The average kid writes it like this. And I just don't know what's wrong with you. That's wrong every time. Ninth commandment of math says 2 or more wrap. Otherwise, you're going to make mistakes on your signs. You're going to have a negative 2x squared. You got a negative 3. Oh, sorry, we have this 3x first, the standard form. You have a negative 4 minus 3, which is negative 7. And you might be watching this and thinking I'm wrong. There's a test not too long ago where you literally had to do one function minus another, and over half my junior class missed it because you won't wrap before you subtract. F composed of G composed of X. The classical notation on this, which is what I grew up, looked like this. I don't know why we don't use it anymore. I really don't. But G of X is 2x squared plus 3. So we're actually finding F of 2x squared plus 3. Which means that every x in f becomes 2x squared plus 3. So it's going to be 3 times 2x squared plus 3, and then minus a 4. Don't forget about that guy. Distributive property kicks in. 3 times 2 is 6, 6x squared. 3 times 3 is 9, 9 minus 4 plus 5. 19, find g over f. Literally put g over f. You don't have to do long division or anything. It's just put g over f and state the domain. The domain comes from this, the fact that you cannot divide by 0. So 3x minus 4 cannot, shall not be a 0. 3x cannot be 4 because you can add 4 to both sides. X cannot be 4/3 because you know how to divide by 3. And in 20 and 21, which are the difference quotient, which is a very big deal for you next year. So first we're going to find it for f of x. This says every x becomes x plus h. It's 3 times x plus h, and then minus a 4. Take away the original function. Don't forget to wrap if it's 2 or more things. Take away 3x minus 4, all sitting pretty over an h. Now, 3 times x plus h is going to be 3x plus 3h. Don't forget about the take away the 4, and then take away 3x plus 4, all sitting pretty over an h. Gone, 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 gone. You have 3h over h, which is just 3. It's also known as the derivative, or the instantaneous rate of change. 21 is going to be a little bit longer because there's more of it. You got to square some stuff. And the first thing I'm going to do is go off to the side, and I'm going to figure out g of x plus h, which means that every x in g becomes x plus h. Now, if you're going to square something, you're going to write it twice. So I'm just going to do that right here. X times x is x squared. Don't forget you have a 2 there. X times h is xh. H times x is also xh. Those are like terms, so plus 2xh. And then h times h is h squared. And there's a 2 out front. So when I do this math, I'm going to have 2x squared plus 4xh plus 2h squared. And I'm supposed to take away g of x, which is 2x squared plus 3. Again, 2 or more terms wrap all over h. Now, whatever you take away cancels out with something else. I forgot the plus 3, didn't I? Plus 3. Those cancel. So whatever's in parentheses is going to cancel out with something outside. That is just how this thing works. This is going to leave me with 4xh plus 2h squared. Both pieces sitting over an h. And then we're going to reduce. Okay, I can throw away one h from every single piece, and I'm left up with 4x plus 2h. Now, there is a pattern to these things. There is. There's a shortcut to find the difference quotient. You want to sit down and figure it out, you figure it out. It'll save you a lot of time. Anyways, I'm done. Hope you enjoyed the boring math lesson, but I did over half your homework for you. I did. Swear. You're welcome.